All right, hello Algebra 2 students, and welcome to the absolute value kind of day number 2, looking at absolute value functions and what they look like and all the different features that we're going to take a look at. So let me get right into what we're going to do today. We're going to look at writing equations of absolute value functions from tables. So let me start with, here's a table of values, and so let's go through and let's start with plotting points here. So if I go through negative 2, 1, there's a point. Positive 1, 2, there's a point. Positive 4, 1, there we go. 7, 0, and 10, negative 1. So if you take a look, there is the absolute value function that we're taking a look at, okay? And so we just connect that piece up, and then I can also connect that piece up. Now, in order to do this, we're going to kind of assume that that top point, the positive 1, 2 here is our vertex, when we can kind of confirm that, because if we're looking at that point right there as our vertex, we can then go down 1 over 1, 2, 3, down 1 over 1, 2, 3. So we can see that these 2 points right here do match up. Let me put that in a different color. These points match up on either side of that vertex. So we know that there's kind of some symmetry going on there with our problem. Okay, so there's our absolute value function. So now if we're talking about the slope, so if you notice, we kind of already talked about that. I went down 1 and over 3. That means the right branch has a negative 1/3 as a slope, okay? And therefore the left branch has a positive 1/3, that it is increasing, okay? So there's our slopes that we have. That means since this is opening down, we know that A is going to be negative, and we use the 1/3, so the right branch. So A is a negative 1/3. Okay, that's kind of the slope of that absolute value. And remember, H and K are just the coordinates of your vertex, which we had said up here. We kind of talked about that already, that the point 1, 2 is the vertex of this absolute value. So H is 1, and that means K is 2. Okay, so we have that information. Does the V open up or down? Okay, obviously we talked about that. It opens down, which matches up with the fact that A is negative. Okay. We said we've got H and K, therefore our vertex as we put this together is the point 1, 2. Is the vertex a maximum or a minimum value? Again, if we go back up, it is a high point of the vertex and everything goes down from there, which means the vertex is a maximum value. It is the high point of our graph, okay? If we keep going, they ask us to identify then the axis of symmetry. Remember, axis of symmetry is always a vertical line, so it's an x equals equation. So if we go back to our graph, our axis of symmetry goes right through the vertex. There it is right there. There's our line of symmetry. And therefore, that has an equation of x equals 1. Okay, it goes right through that. So therefore, x equals 1 is my axis of symmetry. Okay, not 1, but x equals 1. Remember, that's an equation of a line. So then when we are asked to write the absolute value in vertex form, one thing I want to remind you is vertex form in general is y equals a times the absolute value of x minus h, and then we've got plus k at the end. Okay, so if we're going to write it in that vertex form, we've already got the y equals. We said our a value was negative 1/3 back from the previous slide. Absolute value of x minus the x coordinate of our vertex was 1. I can put that in there. Plus the y coordinate of our vertex was 2. So right here is the actual equation that fits the absolute value. Okay, so we have, there's the equation of our absolute value function. So now if we go through and we look for our y-intercept, if I go back to the graph, if you notice, it doesn't look like it crosses at a real nice point, the y-intercept. Okay, we do have one x-intercept that crosses at a nice point, and therefore we might be able to figure out another one. But I'm going to use the equation so I can mathematically do this, which means, remember, a y-intercept is when x equals 0. So I'm going to plug in 0 for x. 1/3 times the absolute value of 0 minus 1 plus 2. And now we can get an answer as we work our way through this. Okay, so as we do that, I get -1 inside the absolute value. Absolute value of -1 is +1. So we have -1/3 times 1 plus 2. So now if we just keep simplifying, this piece then gives me a -1/3 when I multiply, and -1/3 plus 2, we're taking away a third, is 1 2/3, or you can also write that as 5/3. That is my y-intercept for this problem, 1 2/3 or 5/3. And if we go back to the graph just to kind of double check, if you notice, obviously we don't know for sure where that point is, but it does look like we're at about 1 2/3. So it does fit with what we're talking about. Okay, so we're good on the y-intercept. Now I need to find the x-intercepts, which again, we do have that turn out to be, there is a nice one right here, okay, on the graph. We could probably find another nice one on the other side by using symmetry. Okay, matter of fact, if we talk about that real quickly. So here's one x-intercept right there, is at 7. Well, if I use the concept of symmetry, I am 1, 2, 3, 4, 5, 6 spots away from my 6 units away from my line of symmetry. So if I match that up, we're going back to the idea of geometry here a little bit. I can go 1, 2, 3, 4, 5, 6, okay, units away, which means we would be at a -5. So it should cross right about there. So those are, just using the graph, we can come up with that. However, a lot of times you're not going to have nice x-intercept, kind of like we didn't have a nice y-intercept. So again, I'm going to use the equation just to confirm that instead of the graph. So remember, an x-intercept is when y equals 0. So I'm going to set my equation equal to 0. So we have -1/3 times the absolute value of x minus 1 plus 2, and I'm going to set that equal to 0. And now we can solve for the x-intercepts just like we did when we were solving absolute value equations. That's why we started with that, okay? So we got to isolate the absolute value is the idea. So I need to get rid of the +2, the +2, and the -1/3. So step number 1, let's get rid of the +2. -1/3, absolute value of x minus 1 equal to -2 then. Now I need to get rid of the -1/3, so I'm going to multiply by the reciprocal to get rid of it. Those will cancel out, leaving me with the absolute value of x minus 1 equal to a +6. And now I'm ready to go through and break this up. So what I'm looking for are the values that are 6 units away from 0, which means x minus 1 equals 6, and x minus 1 equals -6. Okay, those are both the ones on a number line that are 6 units away. And now we solve. Add the 1 over. There's x equals 7, confirming my first x-intercept. Add the 1 to the other side, and there's x equals -5, confirming the second x-intercept that we found from the graph. Okay, so there's the algebraic way. This is the way I want you to do these problems, not just pick it off the graph. I want to see the work that you do, okay? So that you're practicing solving those equations as well. And then the last thing, if we take a look at the domain and range here of our graph. So again, I'm going to go back to the graph for a second. Well, the domain, hopefully you're starting to put this together, that the domain of absolute value is always all real numbers. Because this is going to go to the left forever, this is going to go to the right forever. We can plug in any value of x and take the absolute value. Positive, negative, 0, whole numbers, integers, fractions, decimals, all those different things. We can take absolute value of anything. So our domain will be all, I'm going to put ARN, all real numbers. Okay? Or another way of writing that is we can write it in what's called interval notation. Okay, which I'm going to put a parenthesis, means we're going from -infinity to positive infinity if we work from left to right. Okay? All real numbers, negative infinity to positive infinity. And therefore, the last thing I want to take a look at in this lesson is the range of this graph. Okay? And so if we take a look at the range, hopefully what you're noticing is that there is a high point here, a maximum value. That's kind of why we talked about that. Right there is my high point. And everything else for that graph is below that. What that tells me then are my y values are less than or equal to 2. 2 is my high point. Okay? So if I write that as a range, I would say y is less than or equal to 2. Or if I wanted to write that in interval notation, again, we always go from lowest value to highest value when we do interval notation. So the lowest value would be down here, meaning we're coming from negative infinity all the way up to that yellow line, which is positive 2. So if I was going to write this, we would write this as negative infinity to 2, and now I'm going to put a bracket instead of a parenthesis. The bracket, just like when we talked about open dots versus closed dots, we will take a look at that. Previously, open dots are the same thing as when you have parentheses, meaning we're not including that. Okay, and we always do that if we have infinity or negative infinity, because it's not an actual number that we can include. Okay, so you always have parentheses with that. The reason I'm putting the bracket here is that's representing like a closed dot, meaning I'm going to include that value. Just like over here I had less than or equal to, the bracket is signifying the equal to portion. Okay, so either way, I don't really care which way you write it at this point. The reason I'm starting to introduce interval notation is this is how they do it next year in pre-calculus, so I want to kind of get you ready for that so that you can start taking a look at that. It might be good practice as we move forward with domain and range. Okay, so hopefully that makes some sense to you. What I would like you to do then with this worksheet or with this lesson is work on the absolute value worksheet number 2, and then we will go from there. Okay, so good luck. I hope everything made some sense here, and bring any questions from the lesson or the worksheet to class when I see you next. Okay, good luck.